Today, I'm taking you inside the factory where American attack submarines are manufactured. So, the construction of each of the 68 nuclear-powered American submarines began right here, with the casting and processing of high-yield steel. Building a single U.S. Navy nuclear submarine can take 7 to 10 years from design to commissioning. The process involves thousands of workers, millions of parts, and billions of dollars. The cost of a single American submarine is approximately $4 billion. The U.S. government must therefore carefully consider whether to use taxpayers' money to improve the lives of its citizens or to build more of these submarines. The United States has the largest and most advanced fleet of nuclear submarines in the world. The second country with the most submarines is Russia, with 64, followed by China with 60. However, it is expected that within a few years, China will have the largest submarine fleet in the world. The production of this high-yield steel 80, which you are watching right now, is more expensive than standard structural steel, but it is considered cost-effective due to its critical properties. As you can see right now, the foundry workers are wearing protective suits to shield themselves from the high temperatures of the steel they are processing. While this material cost is higher, it's justified because this special steel provides the strength and resilience needed to withstand deep-sea pressures, which cheaper steels can't safely handle. Overall, it's a premium material, but essential for submarine safety and performance. The U.S. has strict protocols to prevent submarine tech from leaking. A recent scandal involved nuclear subplans being sold on an SD card hidden in a peanut butter sandwich. U.S. submarines like the Virginia class are built using a modular approach. Large sections called modules or hulls are constructed separately, then joined together. This speeds up construction and allows different teams to work simultaneously on various parts. So at this very moment, while you're watching the steel being processed, the submarine's internal components are being assembled in another part of the shipyard. Due to national security, many manufacturing details are highly classified. Shipyards maintain tight security and workers undergo extensive background checks. Modern submarines are designed to perform multiple roles: intelligence gathering, special operations support, and launching missiles, making their manufacturing especially complex. Since the U.S. Navy employs modular construction to build its submarines, you can now see the completed rear section of the submarine and being moved to another building to be joined with the other parts of the hull. Instead of building the submarine as one long hull from start to finish, the shipyard constructs large sections called modules, or hull blocks, separately. Each module is a fully outfitted segment of the submarine, complete with piping, wiring, equipment, and internal systems. This modular method marks a big improvement over traditional keel-up shipbuilding. It reduces construction time, lowers costs, and enhances the quality of the submarines, all vital when building some of the most advanced and expensive military vessels in the world. This video is sped up. Otherwise, moving this extra heavy rear section of the submarine takes an entire day. Virginia-class submarines are built at two major U.S. shipyards through a unique partnership between two companies. The first is General Dynamics Electric Boat, which specializes in final assembly and testing. The second is Huntington Ingalls Industries, Newport News Shipbuilding, which is actually the largest shipyard in the United States. Newport News Shipbuilding, a division of Huntington Ingalls Industries, employs over 25,000 people, making it the largest industrial employer in Virginia and the largest shipbuilding company in the United States. Because Newport Shipbuilding builds nuclear-powered submarines and aircraft carriers, it operates under tight security protocols, including security clearance, information control, and no phones or photos. As you can see right now, the middle section of the submarine is being moved into the assembly hall, where it will be joined together into a single unit. The full assembly of the submarine's hull takes place about a year after production begins. However, completing the submarine requires installing all the technologies, which takes several more years. After the interior of the submarine is completed, a ceremonial event takes place called the submarine christening, during which a bottle of Moet and Chandon champagne is used. This is the rollouts of the USS Montana, USS Massachusetts, and USS Delaware submarines. They were launched and rolled to the sea between 2018 and 2025. USS Montana is a Virginia-class submarine. It is over 370 feet long and weighs more than 7,800 tons. It is powered by a single S-9G nuclear reactor driving a pump jet propulsor with a speed of around 25 knots. The submarine has a crew of approximately 135 sailors. USS Delaware has nearly the same specifications. Its construction innovations include modular construction, a reduced parts count, and improved maintainability. The keel of the USS Massachusetts submarine was laid in December 2020, and delivery to the Navy is expected by the end of 2025. Incorporates life cycle cost reductions and improved reliability systems. Uses high-yield steel 100 for the pressure hull. Its every weld, valve, and reactor component is inspected under strict Naval Nuclear Propulsion Program standards. It is part of a multi-billion-dollar U.S. Navy contract fueling employment for thousands of welders, pipe fitters, electricians, engineers. Constructed under tight security and quality controls, with many workers holding security clearances. In 2024, during the submarine's first meal aboard, the crew enjoyed classic New England favorites, lobster rolls, clam chowder, and Boston cream pie, as a tribute to its Massachusetts roots. Newport News Shipbuilding is one of only 2 shipyards in the U.S. that builds nuclear-powered submarines, and the only one that builds nuclear-powered aircraft carriers. This shipyard has delivered or is currently building over 20 Virginia-class submarines. It is part of a larger program aiming to construct more than 48 Virginia-class subs through the 2040s. It is also manufacturing sections of the 12 planned Columbia-class submarines, which are set to replace the Ohio-class SSBNs beginning in the early 2030s. Submarines first undergo harbor acceptance tests and then move on to sea trials. During these Navy tests, various aspects are evaluated, including speed, maximum depth, acoustic performance, combat systems, and the safety of the nuclear propulsion system. Once a submarine passes all the tests and is officially accepted, it is commissioned into the fleet. Most workers must be U.S. citizens, and many require security clearances. The yard operates under strict Naval Nuclear Propulsion Program guidelines for quality and safety. The process begins with design and planning, which includes digital 3D modeling and systems integration. Next comes fabrication, where high-strength steel is cut, forged, and welded. After that, modules are outfitted with systems and hardware during the modular assembly stage. In final integration, the full hull is assembled, and major systems, like electrical and nuclear, are installed. The submarine is then launched into the water for testing and trial runs, with any necessary fixes made afterward. Finally, the submarine is officially delivered to the U.S. Navy. So the submarine is fully constructed inside the shipyard's massive indoor facility, known as the Modular Outfitting Facility. The submarine is carefully moved from the construction hall to the outdoor area using heavy-duty transporters, multi-wheeled hydraulic vehicles. These transporters slowly drive the 7,800-ton submarine onto a floating dry dock. The move is done very slowly and precisely to avoid any stress on the hull or systems. Right now, you are watching the submarine being placed on a submersible floating dry dock. The dry dock is then towed into the James River. Ballast tanks are flooded, causing the dry dock to slowly submerge, allowing the submarine to float for the first time. These U.S. Navy nuclear-powered submarines can operate for over 30 years without refueling. Their S9G nuclear reactors produce heat to generate electricity and propulsion for the sub's entire service life. Modern submarines produce oxygen by electrolyzing seawater. They also purify seawater into drinking water, allowing crews to live underwater for months at a time, limited only by food. Because crews are underwater for long periods, submarines are stocked with high-quality food. Fresh ingredients run out after a few weeks, but submariners often say the food is better than on aircraft carriers. U.S. submarines rely on sonar, which is sound navigation, instead of radar or vision, since light doesn't travel well underwater. Advanced sonar arrays help them see enemies by sound, sometimes detecting ships over 1,000 miles away. Stealth is everything. U.S. submarines are so quiet that the Virginia-class subs are said to be quieter than the ocean itself. Crew members even walk softly to minimize sound. Even dropping a wrench can be detected by enemy sonar. Ballistic missile submarines, SSBNs, carry Trident 2D5 nuclear missiles, capable of striking targets over 7,000 miles away. U.S. submarines regularly conduct missions under polar ice caps, surfacing through ice several feet thick. Surfacing through Arctic ice requires precise sonar navigation and a strong reinforced sail. The new Columbia-class SSBNs are projected to cost over $8 billion each, among the most expensive military machines ever built. Submarines often go on classified missions like tracking enemy vessels, laying mines, spying with special operations units, and tapping undersea cables. Their positions are highly secret. Most Navy personnel don't even know where they are. Please write in the comments section whether you think the U.S. government should build more of these beautiful submarines, or if it should rather invest in other types of weapons. Once in the water, the sub is moved to a fitting-out pier nearby. Final systems tests, adjustments, and inspections take place. After completing successful dockside tests, the submarine starts sea trials. These trials are supervised by Navy and shipyard personnel. They include diving tests, high-speed maneuvers, and live system evaluations. Once the submarine passes all tests, it is officially delivered to the U.S. Navy and commissioned into the fleet. But now you are watching submarine production in South Korea. South Korea's submarines are primarily designed and built by Hyundai Heavy Industries. Since 2018, a total of 9 Dosan An Changho class submarines are being built here in 3 batches. These submarines are designed and built 100% domestically. Right now, you are watching the steel being processed and the welding of individual plates for the submarine's outer hull. The submarine has a submerged displacement of about 3,400 tons. It is equipped with a vertical launch system for cruise missiles, like the Huntington. Later batches include air-independent propulsion and lithium-ion batteries. The submarine has an extremely low acoustic signature. Korea is moving toward complete self-reliance in submarine research and development and production. This submarine uses lithium-ion batteries, which are included in newer versions to enable longer submerged operations and faster recharging. South Korea is bidding to export submarines to countries like Indonesia, India, and others. Future versions are expected to include artificial intelligence for combat management and automation. South Korea's KSS-3 submarines are advanced diesel-electric attack submarines with air-independent propulsion and lithium-ion batteries. They displace about 3,400 tons when submerged and have a crew of around 50. In comparison, U.S. Virginia-class submarines are nuclear-powered, much larger at about 7,800 tons submerged, and carry about 130 crew members. Both types carry torpedoes and cruise missiles. The KSS-3 has vertical launch systems for cruise missiles, while Virginia-class subs have more extensive missile payloads and additional capabilities like deploying special forces. In terms of stealth and sensors, the KSS-3 has advanced technology optimized for coastal and regional defense. U.S. submarines have world-leading stealth and sensor systems designed for open ocean and global missions. You are now watching workers at a shipyard in South Korea assembling the interior parts of a submarine. Next, the front section, which functions as a closure, will be attached. The first KSS-3 submarine, Dosan An Changho, it took around 7 years from the start of construction to commissioning. Later units tend to be built faster due to experience and improved processes, sometimes around 5 years each. The program has not only strengthened national defense capabilities, but also positioned South Korea as a competitive player in the global submarine market. You are now watching the rollout of the first submarine of this class and the ceremonial outfitting to celebrate the occasion. During the christening ceremony, information about submarine production is shared, showcasing South Korea's research and manufacturing capabilities. After the ceremonial christening, the submarine is launched into the sea, followed by many months of testing and fine-tuning in shallow waters. Submarines have always been key combat units in wartime conflicts, and along with aircraft carriers, are considered some of the most expensive and effective weapons in every war. Submarines can carry a variety of weapons, including torpedoes, cruise missiles, and sometimes even nuclear missiles, making them effective against ships, land targets, and other submarines. There are roughly about 450 attack submarines in the world today. These submarines are operated by various navies for different purposes, including defense, surveillance, and power projection. The exact number can vary as new submarines are built and older ones are retired. Right now, you're watching the production of Saab's attack submarines, focusing primarily on their flagship programs, such as the A-26 Blakinga class, one of the most modern non-nuclear submarines in the world. This submarine is 216 feet long and weighs over 2,000 tons. The crew consists of around 30 sailors. Saab is internationally known for advanced conventional diesel-electric submarines, especially optimized for operations in shallow and confined waters, such as the Baltic Sea. The submarine is built at the Saab Kokum Shipyard in Karlskrona. It's constructed using a modular approach, where pressure hull sections are prefabricated separately and then joined together. High-strength steel and acoustic isolation materials are used to make sure the submarine remains extremely stealthy. Saab submarines are smaller than nuclear-powered ones, but their stealth and ability to operate in shallow waters make them perfect for coastal defense and intelligence missions. The pressure hull is made from ultra-high-strength, non-magnetic steel that can withstand deep-sea pressure. Each module is lined with acoustic insulation and shock protection to reduce noise and increase survivability during combat. Hundreds of technicians, welders, electricians, and engineers are involved. Many operations require security clearance and specialized training. Many components are hand-fitted to ensure tight tolerances and quiet operation. You are now watching the joining of the front and rear sections of the submarine's hull, a critical milestone in the construction of every submarine. The A-26 submarine uses Stirling engines for air-independent propulsion, letting it stay underwater for more than 2 weeks without needing to surface. The AIP modules are built in climate-controlled environments and must be assembled with great precision because of safety concerns involving liquid oxygen and fuel systems.
Down bridge, patch secured.